Hello everyone, I am C. Girish from G136 group. Today I am going to present plan of execution of a project Face Expression Tracker for Dyslexic Children. Overview of the project. The goal is to make learning more engaging and supportive for dyslexic children, fostering a positive experience tailored to their emotional states. The project utilizes a tech stack comprising JavaScript, Node.js, and MongoDB with facial analysis held by APIs to ensure accurate detection. Main components and their communication. Client side, React based front-end interface capture images from the child using webcam. The captured images are then displayed along with results, enabling teachers or supervisors to observe the detected emotions in real time. Server side. Built with Node.js and Express, this component handles incoming API requests from the frontend. It also manages communication with convolutional neural network (CNN) model, which performs facial expression analytics. Next, database. MongoDB stores critical data including user information, session details, and emotion analytics. This setup allows for session tracking and enabling the aggregation of emotional data for reporting and analysis. AI model. The DeepFace CNN model processes the captured images, analyzing facial expressions. It sends emotional predictions, example, happiness, sadness, back to the server for display and feedback on the front end. Here's the input and output screens when the session of the child gets started, grants the permission for webcam. Here the game, which is quiz based, the captured images are analyzed and visual reports are viewed by admin and teacher. Gameplay and image capturing. When the session gets started, child plays the game. Webcam continuously captures frames at predominant intervals, 3 seconds, during gameplay processing. Each frame is sent to the server for emotion analysis using DeepFace library reports. Real-time emotion predictions are displayed, progression and scoring. Underlying data structures, root level fields underscore ID, a unique identifier for each session automatically generated by MongoDB. Child name stores the name of the child for identification purpose. Session ID, a unique identifier for the session which ties together all data for this particular session. Session date, this timestamp for when that session occurred, allowing tracking sorting of the sessions by date and time. Question emotions array. This array contains an entry for in question or task presented to the child, storing emotional data associated with specific task. Question number. The question number or identifier helping to organize and retrieve emotional data as per question basis. Screenshot path. The path to the screenshot associated with the question, allowing visual documentation for each task presented. Images array. Then this nested array stores details for each image captured while the child responds to the question. Image path, the path to the specific image file that was analyzed. Time taken, time in seconds are spent in capturing this image used for tracking response times. Emotions, an object storing the detected emotions and intensity scores for image. This feels like angry, happy, sad, so on, each holding a score between 0 and 1. Additional fields like maximum emotion image could store the image when the maximum intensity of the specific emotion what is detected within this question, aiding in identifying peak emotional response. Maximum emotion images. These fields might be used for storing paths to multiple images where strong emotional response was observed, storing an overview of intense emotional moments during the session. Final analysis, likely used to store summary or aggregate analysis of emotions across all images for question, providing an overall emotional trend. Tech stack and architectural design. When the child plays the game, the child interacts with the game using web-based interface built with React.js. As the application captures images of the child. While the game is in the progress, images are periodically captured to analyze the child's facial expressions and emotions. The middleware used for image storage. Storing images on the server, the captured images are sent to the server using Express.js, a middleware that handles requests and responses. Express.js shows the images temporarily on the server for further processing. Database, which is MongoDB, for storing image and game details. The details of each image are associated with the game session are stored in the MongoDB, a database used for keeping track of the game data. This can include metadata like timestamp, player ID, or game level information. DeepFace CNN model. Admin requests analysis can initiate request to analysis the collected data. This triggers the processing flow to upload images to the CNN model for analysis. Uploading images to the model. The server retrieves the stored images and uploads them to the deep learning model, the DeepFace library, which built on CNN model. Image analysis. Using CNN model, the CNN model processes the images, identifying and analyzing facial expressions to gauge emotions, detect attention levels, or recognize specific facial features. Storing processed data. The analyzed data, such as detected emotions or other facial metrics, is saved in the database, adding further details to the child's gameplay records. Displaying reports to the admin. Once the data is processed and stored, it is presented to the admin in visual format such as graphs or other reports that summarizes the child performance and reactions during the game. User roles and permissions. Child plays the game with their facial expressions being tracked for the emotional analysis. Admin or teacher or doctor manages users, access visual reports, and analyzes the child's emotional response. Key business logic. Emotion-based feedback show motivational messages. Performance tracking. Scores are based on both gameplay performance and emotional stability. Admin reports. Periodic reports for teacher highlights emotional trends and learning progress for each student. Session data retention. Rules for storing and managing each game session. Reporting logic. Customizable filters for generating reports by time range, emotion type, and other metrics. Error handling and notification. Automatic error messages and alerts for admin. Pipeline encounters the issue. Here's the sources and references. How to perform facial recognition with DeepFace. This tutorial demonstrates the setup and use of the DeepFace library for facial recognition in Python, offering step-by-step guidance on implementing facial recognition in the projects. Next, official DeepFace website for installing. The official Python page for DeepFace library provides installation commands, documentation, and detailed descriptions of the library capabilities. MERN stack overview. An introductory article that explains MERN stack components, MongoDB, Express, React, Node.js, and how they work together for full stack web development. React.js learning. React.js guide on Mozilla Developer Network, a comprehensive learning resource on React.js offering a foundation in React's components, setup instructions, and essential components for building dynamic client-side applications. Conclusion and next step. Sentiment analysis for enriched gameplay. The integration of real-time facial expression enhances educational gaming experience for dyslexic children. By detecting emotional states, the system can provide customized feedback and adapt the gameplay to maintain student engagement and motivation. Next step. Model refinement. Continuous refine the AI-driven sentiment analysis model to improve accuracy and expand the range of detected emotions. This will enable more nuanced responses and interventions. Real world data gathering. Expand data by deploying the game in the more schools learning environments. These environments will provide a robust data set for further training model and validate the effectiveness. Broader educational applications. Explore the potentials of the sentiment analysis framework for the benefit of wide variety of learnings beyond just those with dyslexia across diverse educational settings, subject areas. Thank you.